Unit 15, Part 4. So clearly the unrestricted use of existential instantiation is no good. We cannot have that as a rule because it allows us to go from true premises to a false conclusion. For example, in this proof, there are odd numbers and there are even numbers, premise 1, premise 2. Therefore, there exist numbers which are both odd and even. That's false. Some individual A is both odd and even in a number. That's false, right? So we must restrict the use of this rule so we don't go wrong like we have here. Okay. So we're going to restrict the use of the rule, and that's going to prevent us from existentially instantiating in step 4 to the same individual to which we instantiated in step 3, right? That's what we want to block. Let me just point out, the step from 6 to 7, right? Let me ask you as a question, is this a valid inference? Just the step from 6 to 7, is that valid? That is, if you are given 6 as true, are you entitled to infer the formula here in 7 as true? Okay, answer, pause and answer, then come back. Oh, come back. So think about it, right? This is, okay, just think about it in terms of the rules. So in the exam, you will be using these rules and you'll have to ask yourself, oh dear, what rule am I using here? What does that rule say? And what does that rule allow me to do? Is this a hard rule or an easy rule? Is this a rule that requires restriction or not, right? I spent a lot of time in the first couple of parts stressing that, derive what the rule allows you to do from its name so that you could do this, right? What rule allows you to go from here to here? Well, it's an instance. You're going from a singular sentence or an instance, right? Instances are singular sentences, to the existential statement. So you're existentially generalizing. You're using E.g., right? Because you're going to the quantified statement. Which kind of quantified statement? The existential statement. So it's existential generalization. What kind of rule is that again? It's the one that says, if a propositional function is true of some individual, I'm entitled to infer that there exists some x for which that propositional function is true. Wait, that's an unrestricted rule. That's always valid. I can't go wrong. Now, have I done the instantiation right? I mean, have I done the generalization right? Yeah, I have, right? I replaced the individual constant with the same variable, and I stuck an existential quantifier at the beginning of the formula. That is, generalization is the opposite of instantiation, right? If that was a premise and I was instantiating, that would be what I instantiate to, right? So I've written the right formulas down. It's an unrestricted rule. This step is valid. There's nothing wrong with this step, right? And that's okay. You can see why. Right? If you're given as true, this is false. But the question of whether an inference is valid is the question. If the premise is true, does it follow of necessity that the conclusion is true? If you were given as true that the individual A is both odd and even and a number, you would definitely be entitled to infer with certainty that there exists a number which is odd and even. There exists a number which is odd and even. Okay, so there's nothing wrong with that step. The restriction is in the use of existential instantiation. Okay, I said existential instantiation it's a hard rule, but it's the easy hard rule. Why? Because this is the restriction on its use. Right? All you have to do is when you use EI, as you do here, you include as part of the justification flag A, right? Flag A. What is flagging? As Klenk explains it, it's just, so, we have to come up with some way of preventing inferences like this, which gives you many more examples. There are many ways we might do that. This is Klenk's elegant solution for how to incorporate into the rules the restrictions we need to prevent the false inferences. It's just this, right? You just, for existential instantiation, you just write flag A. What is flagging? It's just bringing attention to this letter that we're instantiating to, right? That's just, you're just saying flag, you're just saying hello. There's some issues with this inference that we're making here. You're just bringing attention to it, you're flagging this letter, and we lay down some rules governing flagged letters. The first rule, which is the one which is pertinent to blocking this invalid inference, of this so-called proof. The first restriction on the use of flag letters is the flag letter must be new to the proof. Okay, the flag letter must be new to the proof, right? So we can see here, is step 3 legitimate? Yes, it is, right? You flagged the letter A, you've existentially instantiated from 1. That inference was fine, right? That's a correct substitution. This is a correct substitution instance of the premise for EI. It's a correct substitution instance of the conclusion for EI, right? So we've done the right thing, instantiating. We've written flag A. Okay, did we follow that rule? Have we broken rule 1? No, we haven't. We haven't broken the rule. This letter, the individual constant to which we flagged, is new to the proof. No problem, right? We flagged A. And that's fine, right? Notice that we haven't taken leave of the truth by step 3, right? We were given that there are odd numbers and that there are even numbers. So we're going to say the individual A is an odd number. That's fine. So we have this particular individual number is an odd number. That follows from the fact that there are odd numbers. So let's say it's A. But look what happens in step 4, which is the one we wanted to stop. We didn't want the even number, the particular even number we're instantiating to be the same number, right? So step 4. Step 4 would be an application of EI from 2. It would be an existential instantiation from 2. Okay, now the restricted rule of existential instantiation says you must flag the letter and you must obey the rule that that flagged letter must be new to the proof. And see that we have broken that rule here, right? I've written EI 2 to give the full justification. I would have to say flag A, and that A would need to, the flagged letter A would need to be new to the proof, which it's not, because it has appeared here, right? Be careful, this is something that many students don't do, that when a letter appears, the letter appears, right? Don't write flag A after somewhere down here, right? If that A has already appeared somewhere. I'll be saying something like this again when we get to the hard rule of universal generalization. When you set up a flagging subproof for universal generalization, the flagging step for UG, that counts as the letter appearing, which is why you can't set up for a UG subproof and then existentially instantiate to the same letter. Anyway, more on that when we get to it. So that's why with a restricted rule, this is now in error. This is now an illegitimate move, right? You've made the invalid. So we all knew this was an invalid inference. We could deduce that from our own minds, just thinking of what these things mean. We've now specified the use of the rule, which now matches our understanding of what's true and what's false, what's valid and whatnot. We've restricted the use of the rule such that this is an invalid use of the rule. Step 4, trying to EI here, flag A, no, A is not new to the proof, you've broken the rule. So no good, and thus the rest of the stuff doesn't follow. Okay, so good. Now, with that in place, something else that's crucial for you to grasp is that while existential instantiation, something that's crucial for you to grasp is that the easy rules, the rules that do not require restrictions on their use, don't require restrictions on their use. So don't confuse the rules that require restrictions on their use with those that do. Okay, a crucial point of strategy, says strategy there, comes out of the fact that of your 2 instantiation rules, one is easy, one is hard. Existential instantiation is a flagging rule. You have to, when you do EI, you have to flag the letter to which you're instantiating. But universal instantiation is an unrestricted rule. You do not need to flag that letter. If you have a universal statement, you're allowed to infer that the propositional function in that statement is true of any individual, including an individual that has been flagged at a previous step. That's the crucial inference that you must make from the fact that UI is unrestricted, right? You can still do universal instantiations to the letter A even when A has been flagged in a previous step, right? So there's a crucial mantra of strategy for these proofs is hard rules before easy rules. Do the hard rules before the easy rules. There are going to be two instances of this. So this is before, right? Greater than sign, it means before here. There are going to be two applications of this strategy tip. Do the hard rules before the easy rules. The first is always do existential instantiation before universal instantiation. EI before UI. Okay, this is a very general strategy tip, which you will use pretty much in every proof. Certainly every pure proof. I talked in Unit 14 about the difference between pure quantifier problems and mixed quantifier problems. Klenk is referring to that difference in her very statement of the goals. Yeah, the Unit 15 objectives on the first page, 273, Unit 15, right? The third and the fourth goal, third goal or objective, be able to construct proofs of arguments containing just quantify statements or their negations. That's what we'll be doing that's what she does in section 5. Those are the pure quantifier problems. They're the ones you'll get practice at doing by doing exercise 2 from Unit 15. The next objective, the fourth, be able to construct proofs of argument containing truth functional compounds of quantified statements. Those are the mixed quantifier problems. You'll get practice doing them using in question 4 of Unit 15 exercises. Question 2, question 4, those are the ones you should really pound away at to achieve mastery of proofs in quantifier logic. Right. So, yeah, I'll start the next section and we'll do this proof, which will be an application of this EI before UI point strategy.